In this lesson, we are going to solve systems of linear equations using the method called substitution. And so going over the warm-up, just some things that you should already know. So number 1, 3x minus 4y equals 18. If x is equal to negative 2, then find y. So what we're going to do is we're going to plug in negative 2. So 3 times negative 2 minus 4y equals 18. So all we have to do now is just solve for y. So negative 6 minus 4y equals 18. It's a two-step equation, so I'm going to add 6 to both sides. And I'm going to divide both sides by negative 4. And so y is equal to negative 6. So if x is equal to 2, then y is equal to negative 6. Okay, for number 2, I'm going to do the same thing. If y is equal to negative 1, then I'm going to find x. I'm going to plug that in for y. So negative 7 times y is negative 1 minus x equals 12. Negative 7 times negative 1. I'm going to subtract 7. Remember, the subtraction goes with the x, not with the 7. So I'm going to have negative x is equal to 5, and then I can multiply both sides by negative 1, or divide both sides by negative 1, it doesn't matter. So x is going to equal negative 5. So if y is equal to negative 1, then x is equal to negative 5. Okay, number 3, if y is equal to 1, so you're going to plug in for y. So 0.75x minus 5 times 1 equals negative 20. So 0.75x minus 5 equals negative 20. 0.75x, I'm going to add 5 to both sides. Watch your signs. And so x is equal to, it's going to be negative because negative divided by a positive is negative. And 15 divided by 0.75 is 20. So x is equal to negative 20 if y is equal to 1. Okay, and then the next one, number 4, I'm going to take x equals 2 and I'm going to plug that in right there. So 6y minus 9 times 2 is equal to 21. So 6y minus 18 is equal to 21. I'm going to add 18 to both sides. So I'm going to get 6y is equal to 39. I'm going to divide both sides by 6. Now, if you're doing this on your calculator and you see you get a decimal, I just want you to leave it as a fraction, and so we need to reduce the fraction. So I don't want you to say y equals 39.6 because that's not reduced, and I don't want you to give me a decimal either. So what we're going to do is we're going to say 39 is 3 times 13, and 6 is 3 times 2, so the 3's cancel out, so y is equal to 13 halves. So if you put 6.5, even though that's equal, we don't want to see the decimals. We want to keep fractions. You need to get comfortable with fractions because you use them so much. For number 5, we are going to graph these two inequalities. So I'm going to do the first one in red. So the first one, I'm going to go to positive 3 and start there. My slope is negative 5 over 1, so I'm going to go down 5 and over 1 and do it again. I could also go up 5 and back 1. And when I connect my dots, I'm going to do it with a dashed line because of that greater than, and it's not greater than or equal to, so I'm going to do a dashed line. Arrows. Okay, and then what I'm going to do is I'm going to shade above the line because that's a greater than. So above is over here. And so that's the first inequality. The second inequality I will do in green. And so that one's y is less than or equal to 6. So because that only has one variable, it's going to be a horizontal line going through the y-axis. Horizontal because it says y. If it said x is less than, then it would be vertical. So I'm going to have a solid line going through the y-axis at 6. And it's a solid line because it's got that equal to sign. And then I'm going to shade that, and I'm going to shade it below because it says y is less than. So shading it below will be all of this. And so my solution is this region in here. That's where all my solutions are. So I'll darken that in a little bit. And so that will be where my solutions are. Number 6, I'll again do the first one in red. So I'm going to start at positive 1. My slope is negative 1/3. So I'm going to go, remember that that's the same as negative 1 over 3. So I'm going to go down 1 and over 3. Down 1 and over 3. I could go up 1 and backwards 3. That will be the same thing as well. I am going to connect these with a dashed line. And again, dashed because there's no equal to. And so I'm going to have a dashed line like this. And then it says less than, so I'm going to be shading below The next one I'll do in green, so I'm going to start at -2. That's where my y-intercept is. My slope is +1, so I'm going to go up 1 and over 1. And when I connect my dots, I'm going to do it with a solid line. And so I'm going to try to make this straight. Okay, and then it says y is greater than, so the part that says greater than right there, I'm going to shade above that line. So that's going to be all of this above my green line. So my solution is this area where the red and the green overlap, and so that's in this region right here. Okay, so for the lesson today, we're going to use substitution. So we're going to do just what we did in the warm-up and use substitution in order to solve a system of equations. So before, what we've done is we've graphed these and we've seen where the lines intersect. So we have a line and we have a line, and where they intersect is right there, and we say the ordered pair is the solution. So we're going to do that without the graph, because a lot of times, in fact most of the time, it's really inconvenient to have to graph everything. So we can use our algebra to do that. Now, in order to use substitution, what you want is you want one of the equations to either say x equals or y equals. And so as long as you've got one of your equations doing that, then you're ready to go. So if I look at this first system on number 1, 7x minus y equals 8, y equals 9x. So it says y equals 9x. So if y is the same thing as 9x, then what that means is it means instead of y, I can write 9x. So I'm going to take my first equation and I'm going to rewrite 7x minus, instead of y, what can I write? I can write 9x. Now the reason why we do that is because since they're the same, it doesn't matter. And also it gives us an equation that only has one variable. So if I do 7x minus 9x, I can solve that equation for x. So this is just what we did in the warm-up, except we gave you the actual number. And so you're doing the same thing though. So you're going to have x is equal to 8 divided by -2 is -4. So what that means is it means x is equal to -4. Well, the last part, since I'm trying to solve a system, I found the x coordinate, but I need to find the y. So what I do is I take the x equals -4. Since x is the same thing, I can put it right there. Y is equal to 9 times -4. 9 times -4 is -36. This is the solution to the system, and I did that without graphing. Now, if you think about it, if you were graphing a system and you had to find the point -4, -36, that's going to be a really big graph. And so it's a lot easier to not have to graph that. And so you're just substituting in things for something of equal value. So let's do the next one. So number 2, you'll notice that it says -8y equals x, but if I turn it around, it says x equals -8y. And then the other one says 7y minus x equals 45. Since this says x equals -8y, that's the same, -8y is the same thing as x, so I can just put it right in there. So I'm going to say 7y minus, and then -8y. Put parentheses around what you're substituting in, because then that way you don't make the mistake of thinking, oh, it already has a minus, I don't have to put that minus. You do, because they're both two separate parts. And so then this is going to be our equation. So we're going to have 7y minus a negative, so that's plus 8y. 7y and 8y is 15y equals 45. Divide both sides by 15. And I get y equals 3. So if I was writing my ordered pair, if y equals 3, that's going to go in the y position. I need the x. So what I can do is I can go back up here where it said x equals -8 times y. Instead of y, I do 3. That's -24. And that's the solution. That's where those two lines would intersect if I graph them. Okay, so we're going to go to numbers 3 and 4. Copy down the problems. You will notice that in both systems, one of the equations is already solved for either x or y. So try. I'll give you about 2 or 3 minutes to try and do your best, and you're going to be coming up with an ordered pair to tell me where do those intersect. Okay, what you should have done on number 3, if y is the same as 3x, you're going to take 3x and you're going to put it in place of y in the other equation. So 3x equals -2x plus 5. Now to solve for x, I have to get all my x's on the same side. So 5x is equal to 5, so x is equal to 1. So that's my y, or my x coordinate. So then to find out what y is, I'm going to put it right in there. So y is equal to 3 times 1. That's my ordered pair. 1, 3 is where those two lines would cross. Number 4, this one, it says negative x is the same as y, so I'm going to put it right in there. So I'm going to have negative x plus x is equal to 3. So negative x plus x, that's 0, equals 3. Okay, so that's something we haven't run into recently. If we have something that says 0 equals 3, when is that true? It's never true. What that means is it means these two lines are never going to intersect. So there's actually not an ordered pair. You're going to say no solution. So if you come up with something that's not true, like 0 equals 3 or 1 equals 5, that's never going to be true. So that means that the two lines are actually parallel and they're never going to intersect. There's no solution to that system. So one other thing before we leave 3 and 4 I want to talk about. If you're going to have this solution, if you say the solution is 1, 3, remember from a couple lessons ago we had a warm-up where we checked to see if something was true. And we did this in the lesson as well. You can check and make sure that this is right, because if this is really the solution to the system, it has to work in both equations. So if I take this and I put it in the first equation, 3 equals 3 times 1, is that true? Yes. Okay, and then put it in the second equation. Y equals negative 2 times x plus 5. 3 equals, that's negative 2 plus 5. That's 3 equals 3. That's also true. If it wasn't true in both of them, then you would have the wrong answer. But because it does work in both of them, this is the right answer. And so that's how you can check. So if you're taking a quiz or taking a test, you can always check your answer and make sure. Now on something like number 4, it's a little bit harder to do that, because if you say no solution, what you're really saying is you're saying that these lines are parallel. So to check something like that, you would really need to graph them. And so y equals negative x is going to look like this. And this one, negative x plus 3 is what that would be. And so it would be like this. And so yeah, they look like no solution. So I'd be satisfied with that. Okay, the last two like this that we're going to do, we're using different variables. And because sometimes you see different variables, so instead of x and y, so here we're using c and d. So the way we write the ordered pair is we write it in alphabetical order. So we're going to write c first and then d, or a first and then b. So when you have different variables, just write it in that order and that will be fine. So go ahead and write down the problems and solve for c and for d, and then for a and for b, and then we'll see if you do it right. Okay, on number 5, c is equal to 2d plus 4. So what I'm going to do is I'm going to put that in place of c in the first equation. So 3 now times c. Remember I told you about using parentheses? So you want to make sure you do that. And so now I'm going to use my skills that I've learned before about distributing. So 6d, take away 6d, oh that's gone then. So then I have 12 equals 12. Okay, what does that mean? Remember seeing that before? That's always true. So what that tells us in a system of equations is it tells us, since it's always true, infinite number of solutions. And so if you think about your graph, and when we were solving by graphing, what did that mean? That meant that these two lines are the same. So in order to check that and see if I'm right, what I would do is I would solve both of them for c. So the first one is solved for c, or sorry, the second one solved for c. So I would take that first equation and I would solve it for c. Because if what I just said is right, I should have the same equation. So I'm going to add 6d to both sides. And then I'm going to divide everything by 3. So everything gets divided. So c equals 6 divided by 3 is 2, and 12 divided by 3 is 4, and that's exactly the same equation. So that's why it's an infinite number of solutions. Okay, for number 6, we are going to take the a, which is 1/3 b, and we're going to plug it in for a right there. So 6 times 1/3 b plus 5b equals 14. What you want to have is you want to have only one variable in your equation that you're solving, because you can't solve for two variables if you only have one equation. So what's a third of 6? A third of 6 is 2. So a third of 6b, or a third b times 6 is 2b plus 5b, so that's 7b, equals 14. Divide both sides by 7 and you get b is equal to 2. So as far as my ordered pair, since I have a and b, this is going to go in the b position right there. Now how do I find a? Well, what I'm going to do to find a is I'm going to take this, I'm going to put it right in there. A is equal to 1/3 of 2. Well, 1/3 of 2, that means 1/3 times 2 over 1, you just multiply across, so 2/3 it is, and that's your solution. One really good thing about knowing substitution is if you were graphing this, good luck figuring out that the equations had a solution of 2/3 too. It's kind of hard to see that on a graph. So if it's not nice, pretty integers, then solving by graphing is not very good and not something that you really want to do.